Hey there, everybody. It's Mr. Brennan. I'm really sorry not to be there today. I'm still sick. I was sick the week before break and have not gotten better during the break. In fact, have gotten a lot worse. But I'm hoping to be with you guys really soon. I've got a lesson for you today that I think you can do without me being there. But let's make sure we put our best efforts forward, okay? All right, welcome back, and here's what we're going to do. I'm going to show you 3 images, and each image is going to have its own spectrum to look at. What I want you to be thinking about while you look at these 3, one at a time, is the following questions. What do you think is happening in each of these 3 spectra, and are they related by some underlying idea or mechanism? Okay, so while we're looking at these questions, while we're looking at these spectra and these objects, can you think of something that might unite them? Okay, at the end, as you think about what's going on, you're creating what we might call a model that explains this set of observations. And it's really not important if your model is right or wrong, okay? Just try to come up with something. Let's take a look at our first image. First image is just a light bulb. And here we've got our classic spectrum. And violet on one end with the short wavelengths, green and yellow in the middle, red with the longer wavelengths, and then infrared there on the towards the right. You see somewhere in the red and the infrared, the intensity starts to drop off. And beyond violet, it drops off pretty quickly. But notice throughout most of the spectrum, it's kind of what we might call a full spectrum light bulb. Each color has essentially the same intensity as every other one. This blend of colors is what gives us white light. There's no sort of favored color, if you will. Okay, so that's the first one, a simple light bulb with what we might call a full spectrum. And you see the intensity is pretty even throughout the colors. Let's take a look at the second image. Here's a giant gas cloud with some nearby stars. You see some background stars there, but this giant gas cloud here, excuse me, is lit up. It's a set of gases out in space. And notice here, the intensity versus wavelength. There are only a few colors that are being shown here, and to my eye, I'm seeing some violet. And I'm seeing some blue. I'm not seeing much of anything else, and I'm seeing some red in there as well. Okay? So, this is like a comb of some sort. Only a few of the wavelengths are showing any sort of intensity at all. Okay? So those are the first 2 images. Okay, here's our third and final image. There's a star in the night sky called Vega, and it's part of the constellation Lyra, and it's also part of a grouping in the summertime called the Summer Triangle. This is its actual spectrum taken by a photometer, and you see again its wavelength down here, intensity. I've kind of superimposed an overall shape here, which looks familiar to us, but notice how many dips there are. Okay, lots of dips. These are places where the intensity is dropping very quickly, and these are labeled 4860, 3930. Those are the exact wavelengths that the dips occur at. Okay, so you see there are quite a few. Some of them are pretty major. That means something, right? It means that the star is not quite the same as this light bulb, where we don't see any dips here, right? And in some ways, it's sort of the opposite of this, where like instead of dips, we have sudden peaks that happen. Okay? So our three images show three different kinds of spectra. We might call this a full spectrum. We might call this a, I don't know, comb spectrum. I'm just making up some words right now. And we might call this, let's call it a real spectrum of a star, where there are these somewhat counterintuitive dips in the profile of the star. Okay, so here we are at the task. What do you think is happening in each of these? Do you think they're related by some underlying idea or mechanism? Can you take a few minutes to just think about what's going on, create a model in your mind? What I'm going to ask you to do in a couple of minutes is this. Excuse me. Grab a couple of partners. Work either with at least one person, maybe two or three, and grab some newsprint and some markers. I think the newsprint is over in room 11 with Miss Murray, and I know that Miss Kramer has a great collection of markers, so we can gather those. Okay, here's what I want you to do. With your partners, share your thoughts about your own personal models. Try to come up with a model that everyone in your group feels good about, and then make that model public by drawing on the newsprint what you think is happening. Use arrows, labels, and so on to make your thinking as transparent as possible. We really, really want others to understand our model, so supply as many details as you can. All right? Don't be shy. Take your time. Take 20, 25 minutes to try to get your model on paper. Your model is going to somehow explain what you think is happening in each of those three cases with those objects and their spectra. Okay? When you're done, put your names on the newsprint and then roll up the models. We'll come back to this on Wednesday. There's another activity for you to do today in class. Okay? Hope you are all way better than I'm doing, and I look forward to seeing you soon. Take care.